Rocks. The three types of rocks. Geologists group rocks based on how they were formed. In this article, you will learn about three types of rocks: igneous rocks, sedimentary rocks, and metamorphic rocks. Igneous rocks form when magma cools below Earth's surface, or lava cools at the surface. The lava in the photo will harden into an igneous rock. Sedimentary rocks form when sediments are compacted and cemented together. These sediments may be composed of gravel, sand, silt, or clay. Sedimentary rocks often have pieces of other rocks in them. Some sedimentary rocks are formed from the solid minerals left behind after a liquid evaporates. Sandstone, shown in the photo, is a sedimentary rock. Metamorphic rocks form when existing rock is changed by energy transfer, heat, or pressure. The minerals in the rock change, but do not melt. Metamorphic rocks experience these changes within the earth. Mica, schist, shown in the photo, is an example of a metamorphic rock. Any of these types of rock can change to become another type of rock. Changes from one type of rock to another usually happen over a long period of time. Sometimes rocks change into another type above ground, and other times this process takes place below Earth's surface. These changes are all part of the rock cycle. The diagram of the rock cycle that follows shows how these three rock types are related to each other. The arrows within the circle show how each type of rock becomes another type of rock. The rock cycle. Sediments and sedimentary rock, sedimentation, erosion, igneous rocks, tectonic burial and metamorphism, metamorphic rocks, melting, magma, crystallization, or freezing of rocks. Stop and check. Describe the rock cycle. How are the three types of rocks formed in the rock cycle? Geoscience processes of the rock cycle. There are different processes that can change rock. These processes include cooling and crystallization. Deep within Earth, temperature can get hot enough to create magma, or melted rock. As magma cools, crystals grow, forming igneous rock. The crystals grow larger if the magma cools slowly, as it does if it remains deep within the Earth. If the magma cools quickly, as it does at the Earth's surface, the crystals will be very small. The process of crystals forming from magma is called crystallization. Metamorphism. This word means to change form. A rock undergoes metamorphism if it is exposed to extreme heat and pressure within the crust. In this process, the rock does not melt all the way. A metamorphic rock may have a new mineral composition and/or texture than before. Weathering and erosion. On Earth's surface, water, wind, ice, and even plants and animals wear down rocks. Over time, they can break large rocks into smaller pieces through a process called weathering. Water, wind, and glaciers carry these pieces from one place to another. This is called erosion. Sedimentation. When small pieces of rock created during weathering and erosion are deposited somewhere, the process is called sedimentation. Sediments can be compacted and cemented together to form a sedimentary rock. The rock cycle really has no beginning or end. The processes involved in the rock cycle take place over hundreds, thousands, or even millions of years. So even though it seems that rocks remain the same, they are slowly changing. Earthquakes and rocks. Seismologists are scientists who study earthquakes. Seismologists have found that ground shaking is a primary cause of earthquake damage to buildings, roads, bridges, and other objects built by humans. When there is a lot of ground shaking, buildings can be damaged or destroyed, which may harm the people who are inside or near them. Seismologists have analyzed and found patterns in data from areas that have experienced many earthquakes, such as San Francisco. For example, during an earthquake, areas of land made up of soft soil experience more shaking than areas that have a harder soil. Soft soil is usually made up of sedimentary rocks like sand, mud, and gravel. Soft soil amplifies, or increases, the ground shaking caused by earthquake. In areas with soft soil, more energy is transferred from the earthquake to buildings. So there is generally more damage caused compared to areas with harder soil types. Soil made mostly of metamorphic rock is harder than soil made of sedimentary rock. Areas of land made up of soil that is mostly metamorphic rock experience less shaking than areas of soil made of sedimentary rock. Soil made mostly of igneous rocks causes the least amount of ground shaking. Soil composition is only one variable that determines how ground shaking occurs during an earthquake. Another variable that determines the amount of ground shaking is distance from the location where the earthquake has occurred. Stop and check. What is the relationship between the type of soil and the level of ground shaking in an earthquake?